Electronics engineering is exciting and terrifying at the same time, and we've seemed to have come across a nice combination of effort that we think gets the best outcome for electronics engineering. And that's primarily between doing a bunch of work in the circuit board design itself and then making a circuit board as quickly as possible. These are the circuit boards that have come back for our new industrial IoT data logging device called Cranio. The fun part starts now. We get to put it in the machine, place the components on there, put it through the oven, and basically fire it up for the first time. Then we will see if the smoke comes out. And there's a constant sort of running joke that magic smoke comes out, you want to try and put it back in again, you've learned something. So let's unbox this and show you the process that we go through to make IoT products. Ta-da, here you go. So that's kind of what you'll see. Usually they're packaged up like this. We basically panelize our boards into about an A4 size, usually because that's the normal size to work with for the stencil machines. I'm going to cut my hand off by doing this. This is always really exciting part of the process for me. It was always really daunting where you'd basically spend all this effort to create the designs and you would have to wait. The waiting was the hardest part. It's thick, it's weighty, a lot of copper in that. The process used to be, you would basically send away for the boards and then you would go and purchase the components from different suppliers around the world. And within that time, they would sort of align, you'd get your components back and you'd get your circuit boards back and probably either hand place them with tweezers for a very short run to be able to do your prototypes, or give them to your circuit board assembly house. These days, it's a little bit different. With the international chip shortage, the components are the hard part. So the engineering process has changed. We used to be able to select chips and then put them on the prototypes, and if they don't work or we find bugs, then we can change them. But now we're having to basically be locked into utilising specific chips, which creates a bit of a conundrum because every chip has a bug, and the engineering work required to engineer around those bugs is twofold. There's the electronics engineering work and there's a lot of firmware engineering work. Most bugs will be documented in a data sheet. Some of those data sheets can be 2,000 pages long, and you've got to go and spend enough time to be able to understand where that bug might be. So the balancing act that we've found at Element is a combination of utilising the reference designs that the chip manufacturers give you and then going and making a circuit board. One little trick with stencils is that the stencil manufacturer may not always use your particular stencil layout. So if you can see here, some of these pads here are specific design for that particular component. So to see that crazy little cutout here. Sometimes the stencil manufacturer will just use a generic pad, a generic design, and that can affect your design of your circuit board. Once we've received the stencil, we'll go back to the electronics manufacturing files we sent off, ensure that the stencil has the correct apertures that we actually asked for, otherwise we'll request a new one. Sometimes you actually specifically have to ask, please use our stencil file. Unfortunately, it's just the way it is with some suppliers. We're very lucky enough to be able to have the pick and place line here, to be able to turn things around as quickly as possible. We often run firmware development in parallel with the electronics development. We call them Frankenstein prototypes. Most chip manufacturers will have a prototype board that you can then wire together with another prototype board, and you make this Frankenstein box. And the firmware engineers can be sure that those demo boards are going to work. Just the wiring between it may create some small issues, but they can usually get around those things. And they can be creating their firmware in parallel with the electronics design to be able to create the board. So hopefully by the time this board is ready to be used, they've got firmware they can drop straight onto the board and then they can basically test. Hopefully it will do the majority of what we intend it to do straight off the bat.